Hello, welcome back. Uh, Here we'll see the analysis problems, typically 2 marks questions in the gate examination. Okay, let's get started. The first question: a simply supported pre-stressed concrete beam 6 meter long, 300 mm wide. Its gross depth is 600 mm. It is pre-stressed by. Okay, let's take the all the values which has been given here. So this is 6 meter long. There's one important point to observe. This 300 mm wide and 600 mm deep by horizontal cable tendons at a uniform eccentricity. Remember, this is an uniform eccentricity of 100 mm. The pre-stressing tensile force in the cable tendons is directly the P is given. Neglect the sulfate of the beam, the maximum normal compressive stress in the beam at transfer. So beam at transfer, again, this is another important point to be careful about, whether it's at this transfer level or it's at service level. So you are supposed to know. So this is what they have given. So beam with an uniform eccentricity, there is a pre-stress here. Okay, so there's a pre-stress here. This is P. Now this width is 300 mm wide and depth is 600 mm. Okay, this is my center line. So this is where my P is acting. So that's good. So what they're asking, because eccentricity in the downward direction, this part will be under the stress distribution is going to be. I'm sorry. It is going to be an P by A. I'm sorry. This is how this stress distribution would be. This is the uniform stress distribution because of the direct stress P by A. This is positive in terms of like compression, and here this is because of the eccentricity. This eccentricity is because of P by Z. This is also the top. This is going to be P by Z, and again this is going to be negative and this is going to be positive, that we know. And here so at the transfer stage, okay, at the transfer stage they're saying that like you have to neglect the sulfate of the beam. Okay, when you neglect the sulfate of the beam, is only because of the pre-stress. So, and what they're asking the maximum normal compressive stress in the beam at transfer. So where the maximum normal compressive stress will happen, it happens at the bottom, because this is positive and this bad positive, they will add it up. Okay, this is add up, and here they will actually, this is positive, this will negative. So the answer has to be for our FC maximum is equals to P by A plus PE by Z. So substituting that everything into the equation, substituting here P is equals to 1000 kN in terms of Newton and divided by area 300 by 600 plus P again same, P is equals to 100 mm, and here this is Z, it is I by Y maximum, so the Y of this particular fiber. So I is equals to BDQ by 12 over 300. So this will give me 5.555 and this will give me 5.555. If I add that one, so it's going to be 11.22. So therefore the answer would be here it is C. The answer is C. Come to the second question. A concrete beam of rectangular cross section which is having an a cross section 200 mm by 400 mm is pre-stressed with a force of 400 kilonewton as an eccentricity of 100 mm. Okay, remember this is not 100 meter. Oh god, this 100 mm. The maximum compressive stress in the concrete is again with the same formula. P by A plus P by Z. Okay, so everything substituting here, we get the answer. Substituting the corresponding values here. So here instead of I by Y, I get it as like BD square by 6. So we know for a rectangular section, the section modulus of for an extreme fiber, it is BD square by 6. So substituting that, I will get the answer as 12.5. Therefore the answer is A. Now coming to the next question. The next question is a concrete beam pre-stressed with a parabolic tendon is shown in sketch. The eccentricity of the tendon is measured from the center of the cross section. That's fine. The applied pre-stressing force at surface is the P is equals to 1620 kilonewton. The uniformly distributed load of 45 kN includes the self-weight. Okay, so including the 45 kN load, is including the self-weight. The stress in the bottom fiber at mid-span is. So when they are asked the including the load, live load plus self-load, what they are asking is the ultimate one. Okay, this is the final one. So for the final one, where they are actually asking at the bottom fiber. So I know there's going to be a direct stress P by A, and there's going to be an, because this is having an eccentricity, and this is where I need to calculate the stress. So at that point, the eccentricity is E mid. Eccentricity at the E midpoint is equals to, it is 145 millimeter. Okay, so it is positive eccentricity, it is downward eccentricity. There's going to be, and the bottom fiber is going to be PE by Z. Okay, and again, because of the live load and the dead load, this portion, okay, the bottom portion is going to be under tension. So there's going to be, this is going to be MD by Z minus ML by Z. Okay, so what is MD and ML? So they are not given separately, because it's also an uniform, live load is also uniformly distributed load, and dead load is also uniformly distributed load. I can combine them. So therefore the moment is going to be given by how much? W square by 8. So it is load W, it is 45 kilonewton. L is equals to what? The length is 7.3. Okay, 7.3 square by 8. I get so much. M, I will get it as 299.8 kilonewton meter, and Z BD square by 6, I will get it as 46.875 10 to 6 mm to the power of 3. And substituting everything at the bottom, at the center of the beam, it is P by A, it is PE, E is equals to 145 mm given, so this is Z value, minus combinedly live load plus dead load, it is 299.8 in 10 to 6 divided by 46.875 in 10 to 6. So I get this one. So final answer I'm going to get 2.9 Newton per meter mm square. Okay, the answer is, it's actually compressive. The answer is B. Let's go to the next question. So I'm going to erase this one for the easiness of doing the next problem. Fourth question, a simply supported Prestessed concrete beam is 6 meter long and 3 mm by 600 mm. It is It is 6 meter long and 300 mm by 600 mm is the cross-section dimension. It is pre-stressed by horizontal cable tendons at an uniform eccentricity, again 100 mm. The pre-stressing tensile force in the cable tendons is again 1000 kN. Neglect the self-weight of the beam. The maximum normal compressive stress in the beam, again the same formula. Okay, it is P by A plus P by Z. Okay, substituting everything here. I get answer as 11.11 Newton per mm square. Look at this. This is the same problem which has been given in the problem number 1. So it has been appeared in the some other GATE exam in the different year, and it's very common in GATE exam that they will repeat the concepts, not the same questions. So you will get lucky if you get this kind of thing. Of course, you should know the concepts. Next, a concrete beam of rectangular cross section is 200 mm by 400 mm is pre-stressed with a force of 400 kN at an eccentricity of 100 mm. The maximum compressive stress in concrete is, again the same kind of question. The answer is A. Sixth one, a concrete beam of rectangular cross section size 120 mm width, 200 mm depth is pre-stressed by a straight tendon to an effective force of 150 kN at an eccentricity of 20 mm below the central axis. The stress at the top and bottom of the fiber is. Okay, so this is for the top, it is P by A minus PE by Z. Okay, for the bottom, this is F top and this is F bottom. So this is P by A and this is PE by Z, because the above the neutral axis this will be under tension, and below the neutral axis this will be under compression because of the eccentricity. So substituting the values here, So P is 150 kilonewton divided by area 120 by 200. The minus is for the top it will be negative, for the bottom it's going to be positive, that's why it is minus and positive. So both is going to be the same, only the sign will differ for the top and the bottom fibers. So again it is BD cube, it is P into E and divided by Z. Z is nothing but BD square by 6. So this first term comes as 6.25, second term comes as 3.75. So therefore, subtracting this one from here, F top I get 2.5 compression. Okay, look at this is because I have taken compression as positive. The answer is coming as positive, so therefore it is compression 2.5. Stress, that is Newton per mm square, and the bottom it is 10 megapascal in compression. Okay, so this is all about the previous question. This is all they will ask in the gate examination so far. Analysis and the introduction to the Prestessed and some of the very basic questions. Okay, uh, hope if you have any questions, just throw me in the comment section. We'll try to solve and post that video. Thank you.